Welcome back to Additional Mathematics syllabus code number 4049, where we look at connected rate of change / rate of change part 3, where we look at another exemplar question here. Alright, so when I see two diagrams and I see part A, part B, part C especially, there are two parts to the question. I'll be like, walao very long-winded, sia. Alright, so we will tackle the question slowly and I will guide you guys on how to unpack this question. Alright, so let's read the question first. A water dispenser in the shape of a cylinder with radius 10 cm is filled with water. Alright, so after every line, I will stop and highlight the keywords. So you know that there's a water dispenser. It's in the shape of a cylinder with radius of 10 cm. And which is filled with water. This is a very good clue. Why? Because this shows that we know that there is water, and so you know that there's water. Water is present. Okay, there's water present. Alright, so what else do we know? Let's look at the second line, yeah? So the water is dispensed. Water dispensed at a steady rate into an empty cup in the form of an inverted cone of height 8 cm and your base radius 4 cm. So what do we know? We know that the water pour inside lah. Okay? But I'll show you guys a real life analogy shortly. Alright? So, but before I go into part A, I want to give you guys this real life analogy, yeah? Making hot tea. Let's say I want to make some, maybe let's say green tea, alright? So, when you want to make hot tea, right? Before making green tea, you will need your, maybe let's say your tea bag or whatever, like maybe this thing here, your tea bag. And then you'll need a kettle. So I'll just draw the kettle and then there's a ring on top. Yep, like that. That's my kettle. And then I have my cup. Alright. So let's take your kettle now as the water dispenser. And your cup as the conical cup. Alright, I want you to have this analogy. Think about it. When you need to make tea, you have to pour water from the kettle in the cup, correct? With your tea bag also. Correct or not? Correct, ah? Okay, so this is the analogy I'm going to give, but I'm not going to give any spoilers first. This analogy, I will use it later in part B. That is all I will let you know first, because I think that we need a bit of an analogy so that this will be easier to understand. Alright? So, let's go back into the question now, yeah? So we know what? After part A, after t seconds, the depth of water in the conical cup is x. Alright? Show that the volume, keyword show, show that the volume of water, the volume is in the, where? In where? The conical cup, right? Is pi x cubed over 12. Alright? We have to show it in this form. Alright? So, they talk about what? Conical cup, correct? So, when they talk about conical cup, right? Let's identify the shape of the conical cup. So, the conical cup, we know that this is in the form of a cone shape. And let me ask you guys a question. Okay, this is related in both A math and E math. So, A math, E math. When you see the word cone, what will you think of? If you don't know, it's okay. I'll review it shortly, yeah? So, when you see the word cone, I want you to think of similar triangles. And in the O levels, they like to test similar triangles a lot. So when you see cone, think about similar triangles. Why? I will share with you shortly, yeah? So if you look back at this diagram here, can we say that this triangle and this triangle are similar? Some of you will be like, huh? Similar meh? Yeah lah, the shape looks like it. But I want to tell you that this is 100% similar. I can guarantee you that this is a similar triangle. Alright, I will use letters. I will show you guys angles to prove. Alright, I'll be using similarity tests to do so. Alright, so small triangle. Let's call this A. Let's call this, actually I don't use black. I use yellow. A, B, C. The blue one here. A, D, E. Alright. So let's go. Alright. I will show you how. Can I say that this angle and this angle they are the same? Can I say so? This angle and this angle. Can I say that angle ABC equal to angle ADE? Can or not? Can. And what's the reason? Corresponding angles. Okay, corresponding angles is aka your F rule. So I'll draw a very big F here. F, where this angle and this angle is the same. And if I'm not wrong, F rule is just these two angles are the same. And maybe if I add an E lah, huh? This angle and this angle is the same. Alright? So, but F rule, I'll just say these two are the same. And if I were to draw a F right now, alright? So, I draw the F, I show you, Can I say that this angle and this angle are the same? Yes. Alright? Because of corresponding angles. And what else can I say? Can I also say that this angle and this angle, they are the same? Can also, right? So your another A will be angle ACB equal to angle AED. Again, because of corresponding angles. Do you see the F here? This is a slanted F. So what can we say? This angle and this angle are the same. Okay, this should be your similar triangle. So what can we say? We can say that therefore triangle ABC is, I'm trying to write out all in one line so that it's easier. Okay, so I write on top here, can? So triangle ABC is similar to triangle ADE. This is due to your AA similarity test. Okay. So now actually you don't need to write all these, you just need to know that they are similar, but I'm just showing you how are they similar. Alright, so let's look back at the question, yeah? If we know that triangle ABC is similar to triangle ADE, whenever you see similar triangles, furthermore, I want you to know that you can use your ratio. The ratio here will be AB over AD. Okay, AB, AD is the same as BC, DE. Hold on, I want to differentiate the colors. Okay. And what else can we say? AC, AE. Hold on. I write again. AC and AE. So it's AC over AE. Okay? I'm just using the letters to make it clear. So what can we say? If you look at our question stem, right? We notice that the volume here, there's nothing in terms of R. So when we see these kinds of questions, what do we know that we have to find R already. Alright, so how to find R? We know that what? We know that AB is your X. Let's sub in the value first. AB is X. What should I write? What color should I write in? Haven't used yellow yet, right? X over, okay, right here, X over your AD. AD is 8. And then what do you have? You have your BC and DE, right? R over 4. So what do you know? We know that what? For X equals to 8R. Let's find R. Actually, wait, hold on. 4 over 8, which is the same as R over X. What am I doing here? Or you want to make it simple? I'll rearrange. Same thing, 8R equal to 4X. R on the left hand side, more comfortable with it, right? So R will be 4X over 8. This is the same as 1X over 2. Or I can just write it as X over 2. Alright, so now you have your R. Since we know that the volume of the water is x cubed over 12, we must show, right? We know that it is a cone. We have our R already. So we know that the volume of a cone is 1/3 pi R square H. So this will be 1/3 pi x over 2 square, and your H is your X, your depth is X. Alright, and what do we know? We know that I wanted to show you that the water is over here, this one, the one that is in black, this part lah. I'm sure you know, right? Okay, so let's simplify. Remember this indices rule here. When I say A over B, yeah, again, AC, BC. That's what I'm going to say next. Instead, it's in a fraction now. And your C is at a power, yeah? This is your laws of indices. Alright, so let's expand that one out. So this will be your 1/3 pi x squared over 4x. So right, I will throw my x here. So this will be 1/3 pi x cubed over 4. I'll make it into simpler terms. Throw my pi to the numerator. It will be a pi over 3. Alright, so this one, remember, numerator times numerator, denominator times denominator, yeah? So this will be a pi x cubed over 12 cm cubed. And you must write the word shown. Okay, do you understand? So what did I do? The concept here is similar triangles. This is very important. Please put 2 stars on this one. This is important. Alright. So now we have found the volume. You want to take a screenshot of it? I'll let you take a screenshot first. Okay, can pause to take. I'll remove already. See, can remove or not. because I need space for part 2. I mean part B. You want to take photo of the information also can. Like this part, you want to take photo, you can take photo. Okay, pause to take photo. I'm going to remove all the drawing. Okay, fresh start. Nice. So, the next part, part B. This part, in my opinion, is the most crucial part. Actually, B and C are the harder parts. Alright. So, let me shift the hot tea example over here. Oh, poor kettle. Alright, so I'll go back to this example later. But just to let you know, I will come back to it soon. Alright, so look at question stem again. Part B, what they're asking you. If the depth of water in the cylinder decrease, you might wonder, hey, why you change color? You know why? I will tell you why later. Read the question first. By 0.0025 cm per second. Okay, this one, right? cms minus 1. I want to rewrite for you. It is 0.0. Sorry, it is 0.0025 cm per second. Okay, they want you to find the important rate of change of the volume of water in the where conical cup. Okay, so if the depth of water in the cylinder decreased by 0.0025 cm per second, find the rate of change of the volume of water in the conical cup. So you know, if the depth of the water in the cylinder decrease, okay, look at this. Depth of water decreased by 0.0025 cm per second. What can we say? Can we say that this is a rate? So what do we know? We know that what? If our depth is x, what can we say? Can we say that dx over dt is minus, okay, wait, I write minus 0.0025. Okay, why minus? Okay, look out for keywords. Rate of change tip. Okay, I want you to look out for keywords. Like increasing, decreasing. Okay, I'll write maybe in more like you know, increasing is positive. Like, you know, they say green light go, red light stop, right? So increasing, maybe I'll write in red. I'll write in blue. Okay, decreasing. I want you to take note of all these. Because decreasing is negative, your sign will be, your value will be negative, and for increasing, it will be positive. Okay, so right, look out for keywords. And that's why, since the question say decrease, right, it can be, okay, maybe I'll write increased. Same thing lah, decreased. Okay, So if you say it decreased, that's why my sign here is a minus sign. Can or you want to take photo or not? You can take photo first. Pause to take photo. I'm going to remove it already. Then I give you a okay. So always remember to take note of your sign and also pay attention to the question parameters, alright? So they want you to find the rate of change of the volume of water in the conical cup. So what do you know? They want us to find dV dt, isn't it? Because they want the rate of change of the volume. Okay, so let's form our rate of change. Remember, on the most left is what we are going to find. And then this is what they give us, dx dt. And then, what's this one? Times what? dv dx. Why? Think about it. dx and dx can cancel. You are left with dv over dt. Okay? So, it is given to us that the volume is pi x cubed over 12. I'll rewrite this as pi over 12 x cubed. I just shift the x cubed to the side, okay? So, when I see this, what do I know? dv over dx, correct? So this is what? Power bring down, power number minus 1. Basic differentiation, alright? This is your power rule or basic differentiation. Power rule. So power number come down. Pi over 12 times 3. Pi over 4x squared. Okay? So let's find the rate of change of the volume of water in the conical cup. Okay, we have formed our equation, but can we find x or not? Can, right? So how to find x? So let's see. We have our r already, right? What's our r? Never mind, I will do again. So base radius 4 and 8, right? So what do you know? The similar triangle rule again. So it's what? X over, if I'm not wrong, is what? X over 8 is r over 4. You know that your r is half, right? So hold on. So r is half. So it will be, okay, so this is the part. We have to find r in order to get our value for dv dt. I mean, find the value of x, okay? But let's think about it in this way. Do we need to find x or no need? Okay, so let's see. So we have our dv dx, we have our dx dt, and we have our dv dt, right? So what can we say? So I look at it wrongly. My fault. Okay, see, I also forgot about this thing called cylinder. I thought there was only one thing the whole time. Okay, I'm gonna remind myself about this term as well. Cylinder. Alright, so we are now differentiating with respect to cylinder now. Alright, so what's the volume of cylinder, everyone? Ladies and gentlemen, what is it? So the volume for a cylinder, that's a cylinder, pi r square. H, what's your radius? Your radius is 10, right? Pi 10 square. You know what? Ayo, my fault. We shouldn't say the depth of water is X because I forgot about cylinder. Let's change up, everybody. Depth of water will be H. Okay, so depth of water is H, so just let H be. This will be 100 by H. Okay, so let's differentiate now. dV over dH. Okay. Let's change first, So this will be dH, dt, dV, dH. Okay. I'm so sorry, I'm gonna remind you not to copy, So don't copy first, For part C, don't copy, I want to wait until my answers are finalized, then can already. So dH, dt. Okay, so dV, dH. Power rule. Power number come down, power number minus 1. So 100 by H1 minus 1. H power 0 is 1. So 100 pi times 1, 100 pi. 100 pi. Okay? So, can we start? Can, right? So, let's start our rate of change. So, what's our rate of change? dH dt, right? So, dH dt is what? Minus 0.0025 times 100 pi. So let's see what is minus 0.0025. Is I'll change it to fraction. Minus 1 over 400 times 100 sorry, pi. So 100 and 400, this becomes a 4. So this will be minus 1 over 4 pi. Or I'll write it as 0.25 minus 0.25 pi. Okay. So here's the part. What does the question want? This question is out to slaughter. If you don't read properly, you are slaughtered. Okay? So what do they want? They want the conical cup. That means it's the cone. That's when the kettle and the cup come in. So when you want to make tea, right? Okay? As I said earlier, before you make your tea, right? Of course, you will, let's say for some people, they will like put the tea bag inside first, and then, okay, see, the kettle, you have to pour water from the kettle into the cup, right? What does that mean? That means the kettle is losing water. Kettle, I just realized it's in the same color. Wow! Oh my god. Actually, now I'm just gonna delete and I'm gonna write in the new color. Oh, yep, this one can. Okay, so when the kettle, when you pour water into the cup from the kettle, can we say that the kettle is losing water? Kettle, aka your water dispenser, or the cylinder, I'll write down the shape so it's easier for you to understand. This is your cone. This is your cylinder. Okay? And when the kettle is losing water, can we say that the cup is gaining water? Can, right? So, back to this example. They want a conical cup. Now, you know that the rate of change of volume, this one over here, this is what the examiners, they like to test. This one over here actually is the rate of change of the volume of your cylinder. You see it now? So, like what I said, back to the making of green tea, right? So, if let's say your rate of change of volume of your kettle is decreasing by minus, I forgot to add something. Hold on. Oh, never mind, I did. It's changing by minus 0.25 pi. What does that mean? That means that what? The cup or the conical cup, right? AKA is gaining the water, isn't it? Or gaining volume, right? Because at first the conical cup is actually have some water at first, but now it's like a lot more lah. Okay? So now there's a lot more water lah, okay? So therefore, what should your answer be? So therefore rate of change of volume in conical flask is 0.25 pi cm cube per second. Do you understand why is it positive? Because, like what I mentioned earlier, when the kettle or your water dispenser, or if the cylinder is losing water, that means your cone is gaining water. That's why the rate of change is positive. So gaining usually is positive, losing usually is negative. Okay, so that's it for part B. Yeah, you want to take a photo? Pause the video to take a photo, yeah, because I'm going to move on to part C now. Okay, so back to question parameters. This part will be very, very exciting. Okay, you want to take photo of this also can. So take photo, come pause to take photo, come, pause to take photo, Pause the video and take the photo, okay? I'll remove it also. Back to question parameters. Oh, sorry for that. Suddenly the zoom suddenly so big, Super sorry about that. So, hence, part C, Slowly. Okay, I'll erase. Fresh question now. Hence, okay? What's the keyword here? Hence, correct? Calculate at the instant of when the volume of water in the conical cup is 2/3 pi cm cube. They want you to find the rate of increase of the depth of the liquid where? In the conical cup. Okay. This one. Actually, this is requiring a lot of understanding. So, let's look. We can. So, let's see. What do they want us to find? They want us to find dx. Dx dt, right? Because conical flask, your h is x, what? Correct? So, now, let's look back. They want us to find hence, right? So, the rate of change of the volume of water in the conical cup. Okay, just now I forgot to write. You must write. Never mind. Okay, correct. It's correct. You must write d. So what do we have? We have dv over dt, right? Which is 0.25 pi. If I remember correctly, and it should be lah. I mean, that's the answer. Yep. So, now, let's form our chain first, okay? So, what do you have? Left side, we're going to find what is given. So, what is not given now? We have dx over dv. Okay, but we cannot write it like that. Remember, we must write the... Whenever you see this color, you know what I'm talking about. You must write it as 1 over dv dx. Okay, so I already explained to you why, so I won't explain further. So I will write it as like this. Okay, and what is your dv dx? So okay, I'll write it here. dv dx, this is the differentiating of the volume in the conical flask with respect to x is your pi over 4x squared. Okay, how to find x? This part, okay, because a bit more concept now. So, keyword here again, back to question stem. Steady rate, that means it's constant. So what does that mean? Can we say that the volume, oh my god, can we say that the volume of water exiting the dispenser is the cylinder, can we say that it is equal to the volume of water entering the cylinder, the conical cup? Can, right? Because steady rate, what? So let's find the volume of water exiting the dispenser. Alright, so they say what? Given that the volume of water in the conical cup is 2/3 pi cm squared, cm cube. Alright, so actually what can we say? We can wait, the depth of the water in the conical cup is x. Okay, so they want what? The volume of water in the conical cup is 2/3 pi. So what can we say? Can we say that, right, this is the part where it's, of course, maybe this is just additional information, but now that I've looked at it, okay, hold on, I'm reading the question. So because we know that, right, we have the same height as x, so now we have to find x so that we can sub our value in. Okay, so how are we going to do this question, right? Is the depth of liquid in the conical cup the rate of increase, right? So what can we say? We can actually do this. Okay, so what can we say? Let's say we can say that actually pi x cubed over 12 equals to 2/3 pi cm cube. Okay, why? Why? Because, okay, you see, the volume of water in the conical cup is 2/3 pi cm cube, right? So what does this mean? This means that the volume is 2/3 pi, correct? I mean, as stated in the question. So now we see, because you can say what? If the depth of water in the conical cup is x, right? So that the volume is pi x cubed over 12. What does that mean? We can say that what? Can we say that the volume is only affected by the height? And since they already give us the volume of water of the conical cup is 2/3 pi cm cubed, they did not say the height has changed. So therefore, we can actually equate them to find x. So what can we say? We can say that what? Excuse me, 3 pi x cubed cross multiply, which is the same as 24 pi. Or can I just say I times 3 on both sides? Times 12 times 24. Never mind. Just cross multiply, but 2/3. So times 36 on both sides. But I don't want to confuse you, so I'll just write cross multiply. So like that, cross multiply. 3 times pi x cubed, 12 times 2 pi. Okay? So now we can say what? Our pi and pi can cancel, correct? So what can we say? We can say that 3x cubed is 24. X cubed will be 24 divided by 3, which is 8. So x, which is cube root 8, therefore is 2. Okay, so let's start to do the question. Okay, so what can we say? dv dt, okay, this 0.25 pi times 1 over, wait, before that, I will find the value of dv dx. So this will be dv dx, which is pi over 4 2 square. This is 2 square is 4, 4 pi over 4 is just pi. So 0.25 pi times 1 over pi. The pi and pi here can cancel. Therefore, this is 0.25 cm per second. Okay, so this should be your answer. I mean, I don't have the answer here right now, I'm just doing it. Okay, so this is part C, part 1. You want to take a photo? Take a photo first. This one I try to shift a bit to the left side. Then you take a photo. No, this one. Okay, like that. Pause the video to take a photo. Moving on to the last part of the question, and we'll call it a day. Aiyo. Don't know why I just can't erase the things off. I know it has been 42 minutes. Thank you so much. Okay, so let's look at part 2. You have to find the what? The rate of increase the rate of increase of the area of the horizontal surface of the liquid in the conical cup. So what's the horizontal surface? The horizontal surface in this case is the circle. So area of the horizontal surface, the rate of increase of the area of the horizontal surface. What does this mean? This means what? dA over dt. Right, question mark. What did they give us? Did they give us anything? Oh, okay, let's form our thing first. dA over dt. They say hence, right? That means use the previous part. So what do we have? We have dx dt, I remember. And then we will have your dA dx. Oh, why does my dA dt look like that? Alright, I'll write it out again properly. dA dt. Okay, so remember your dx and your dx can cancel, end up is dA dt. Alright, this I'm just using. So dx over dt is what the question has given because they say hence. Hence, keyword hence. Very important, you need to look back. Look back to part B, okay? So we know that what do we know? We know that dx over dt, which is 0.25 pi, correct? So what does this mean? This means that we can say what? Let's find the area first. So we know that area is a circle, pi r square, right? So area of a circle is pi r square. So what can we say? We can say that what? We can say that dA over dr. But now we don't have r. So what? what can we say? dA. Okay, so what? What's your R? We have found it earlier on, right? Remember, we have found in part A where your R equals to x over 2. Sub that inside so we can make dA dx. Do you understand? Because we need to have our x term inside so that we can differentiate. So A will be pi x over 2 square. So this will be what? Pi x square over 4. This will be pi x square 4. Okay, so now, right, we know that your area will be rewritten as pi over 4x squared. So we know that dA dx. Okay, this will be what? Let's differentiate. Power rule, right? Power number come down, power number minus 1. So what? This is pi over 2x. Okay, so we have your dx dt, your dA dx. Now let's start differentiating. So let's start finding the rate of change. So dA dt, this will be what? 0.25 pi times pi over 2. Okay, and what's your x? We have found earlier that your x is, if I'm not wrong, your x is 2, right? Yeah, times 2. Okay, so now let's start to find out. Okay, so 0.25, let's convert it to a fraction. This will be your pi over 4 times your 2 pi over 2. Okay, so right, you know that this is actually, wait, we can just do 0.25 pi times 2. This will be 0.5 pi, or known as pi over 2 times pi over 2. Okay, wait, never mind. I just realized, right, that there's actually no pi. No, we actually got it from part C, part 1. This is your dx dt. Because I realized this is the depth, right? That one is volume. So dx dt is what? The depth with related to time. I'm sorry about that. My fault. So this will be 0.25 times pi over 2. Okay. Times 2, of course. Okay, so this will be what? A. This will be 0.5 or half times pi over 2. This will be pi over 4 cm squared per second. Cm squared per second. Okay, so that is it for your part C rate of change. Alright, I think I will want to remove the image, but you can just take photo of this. Or not, I can just try to remove the image first, yeah? Okay, and yeah, that is it for today. We will call it a day. It's going to be 50 minutes soon. It's about 12:07 AM right now. So I really hope you understand. And I would recommend, right, you guys to actually just listen through, take a screenshot, and then you copy down after that, okay? Because I might make some mistakes. I mean, I did it. I'm doing it in like around late night, so I might make some mistakes here and there. So really just listen. I hope you actually understand. And just now about the 0.25 pi, right? I forgot that it was for dv over dt. It's actually supposed to be dx over dt, where it's the depth. Alright, so you can take photo of this one. You can pause to take a photo, and I will end the video right here. It's gonna be 49 minutes and 50 seconds soon. So I'll end the video now. I'm thank you for staying. I know it's 10 minutes longer than the 40-minute one. Thank you very much. I'll see you guys in the next one.